Alright, so this is the drawing of translation so that you guys can figure out exactly how you need to be able to draw a ribosome to get full credit on your test. Now to start with, what we have is we have these three section pieces of mRNA. So the orange line with the actual sequences that are red, this is my mRNA. So my mRNA acts as the recipe for making proteins from an amino acid chain. Now what I'm going to do is I'm going to come all the way over here. I have these blocked off as like three groups of three nucleotides at a time because each of those is referred to as a codon. Now what a ribosome does is a ribosome reads the codons and matches them to anticodons on other pieces called tRNA. Now the ribosome itself is a big long strand of RNA that folds back on itself and hydrogen bonds with other places on itself. So like part A's on one part will bind to U's on another part. And it's made of rRNA. And that rRNA and some proteins make up the ribosome. So that ribosome has three different sections to it, or three different sites that are active inside of it. Those sites inside of the ribosome are the A site, the P site, and the E site. Now, those three sites each have their own specific job. And the specific job of the A site is to match up with a particular tRNA. So if this is my tRNA, right here, and let's say that the codon down here went CCC, then the anticodon that would be accepted would be G, G, G. So it's because of this complementary base pairing that the codon CCC matches the anticodon GGG, and therefore the ribosome will accept it, but only if it's carrying an amino acid. And the amino acid that it's carrying in this case, you could look up on the amino acid chart, but each one that comes in this site is carrying one amino acid. Now, next to it, in the P site, and the P site we'll refer to as the polymerization site, this particular tRNA, it has several amino acids attached to it. Now I can tell on this one how many amino acids because this codon would have brought in the first amino, methionine, then this would have brought in one, this would have brought in one, this would have brought in one, and then there's the one that this came in to the A site with. So the first one on that tRNA is the one that was brought in with this particular tRNA to the A site. But it's also got the amino acid from here, 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 and here hooked off of it. So 1, 2, 3, 4 more. So this would be all of them. This one would carry a methionine. I haven't defined the rest of these because they're not important to us right now. And then the E site has in it a tRNA. This tRNA actually was holding on to this amino right here. And it used to be in the P site, and at that time it was holding the chain from here to here on this particular site. But when the whole amino, when this ribosome moved over one more spot, this tRNA was in the A site, and what it did is it drugged this entire chain over and hooked it up. So when we define what each site does, we're going to see that. So for the A site, for instance, let's define what the A site does, what its job is. The A site accepts tRNA that matches the mRNA codon. And has an amino acid. So to be accepted, it has to both match the codon and be carrying an amino acid. That's what we refer to as being charged. Now, the next site I want to define is the E site. The E site, when we look at the E site's really simple. This is the easiest one to remember. The E site, quite simply, kicks off tRNAs that has lost its amino. Now, that leaves us with one more site, and that's the P site. This is the hard one. This is the one where all the action's occurring. So, the E site, this has lost everything. It gets kicked off. When that gets kicked off and this one is moving into the P site, the A site will be open again, and whatever the code is here, it will wait for that. Now, why does all of this matter? Well, because of what happens in the P site. That's why all of this matters. So let's look at the P site. This is the one that's got quite a bit going on with it. The P site, right here, this P site, what happens? Where this arrow is pointing, that bond breaks between the amino acid chain and the tRNA. There's energy stored in that bond that can be utilized to hook this chain to that amino as that amino moves in. So, the P site, a P site is the polymerization site, and call it the peptidal site. Don't worry about that, call it the polymerization site, it'll make more sense. So the P site, or the polymerization site, holds the growing amino acid chain alright, and uses the energy released by breaking it free from its tRNA to hook, using a covalent bond, to hook that amino acid chain to the amino that is entering the P site. From the A. So what that means is the energy that was right here is used. This whole chain will stay with the P site. It will be broken free of the tRNA. That tRNA moves into the E site and gets kicked off. This amino acid chain gets brought over here, and the energy that was used to hook these together is used to actually hook that amino acid chain onto that singular amino acid. And that is what you've got to be able to explain what happens to each of these. Now, it might help to remember every single amino acid to become part of a protein has to go ape. In other words, it has to land at the A site, go to the P site, and its tRNA has to get kicked out through the E site.